We're starting this second session with Brian Ford, who's Professor of Bioclimatic Architecture at the University of Nottingham and the head of the School of the Built Environment there. But for many of us, he's also very familiar from some of the buildings that I think you saw in his days as Short Ford and Associates, and then later as Brian Ford and Associates, and then with research projects with WSP Environmental. And of course in our school here, he's very well known for working in our program for many years, both at the master's level and with PhD students. Brian.
Thanks, Simos. Well, good afternoon. I had a brief word with Simos before he came up because I said it's rather difficult to follow this extraordinary set of presentations we had this morning. And well, Simos said, well, you've got two options. You can either disagree with everything that's been said, or you can agree or find some other thing to say. My presentation, there are two parts to it. The first part really addresses some of the issues that I perceive to be pertinent in terms of engaging with what we might call sustainable design in architectural courses or in architectural education. And the second part of it is a little bit about some of the things we're doing in Nottingham in that regard. Right. Oh, no, I've gone too fast. Sorry. I don't normally quote politicians, but I'm quoting Tony Blair partly because I think that within Europe now there's a broad consensus that actually I think most people would subscribe to this view that there's a major crisis that we face and which we must address aggressively. But I've put this on the screen because, of course, on the other side of the Atlantic, there's another major politician who actually takes a different view. And it's not just him, it's a large section of that society. And I think we shouldn't forget that. We have a mountain to climb in terms of really, I suppose, facing up or addressing this as an issue. And I think actually a large part of North American society is in denial. Now, the statements from politicians really are rather jaundiced and, like many, rather cynical. But statements like this from a very prominent architect, Ken Shuttleworth, ex, of course, of Foster's, do encourage me, I think. Because here is someone who's very prominent and he's addressing some of the issues that we recognize as being problematic. We may not agree with his analysis, but at least he's saying something passionate about addressing the problem. And he, in this BD article, he ended up saying architects are in the best position to effect change. But this leaves the question of how, and I think this is the main thing that I want to address, that very often we've been beaten over the head very professionally by Sue and Thanos giving us a picture of the problems ahead. But the problem with beating people over the head is that everybody then ends up feeling guilty and inadequate. So rather than leaving people feeling guilty and inadequate, we must begin to address the issue of how we tackle the problem. Because we know architectural students, architects in general, aren't getting it. They're not getting it in general. Why? Well, maybe it actually has something to do with us and in our approach to the way we impart knowledge and skills and how we crucially integrate this in the design process. And for me, the major issue is how we do integrate our knowledge and newfound skills into the design process. So how we improve knowledge and skills, we've got to, I believe, also promote an evidence-based approach to part of that design process. Now, this is anathema, actually, to many architects. Architects in the past, I believe, have primarily proceeded mainly on the basis of their intuition and their previous experience, which has done many people very well for many years. But it's, I think it's interesting to note that many architects don't really come into their prime until they're well into their 40s. So they're building a lot of experience on the way. And you need that practice, of course. But basing practice purely on intuition and experience, I don't think is good enough anymore. Architects also, by and large, are innumerate. Other people have said that it's very difficult to interest architectural students in numbers. And yet, I think it is interesting. My own experience, about 20 years ago, I spent a couple of years in the office of Max Fordham, who's the M&E engineer. And in the process, I worked with some of the people in Ted Cullinan's office. And by working with them, Alan Short and others remarked that they had not appreciated before that an evidence-based approach, i.e. doing some critical analysis on the way, can actually help to refine and develop ideas. And it needn't result in the tail wagging the dog, but it can help in that process. And that's what began interesting me, how we integrate these things in the design process. Also fundamental, of course, is to promote a cross-disciplinary or interdisciplinary approach. And this, again, in schools of architecture is difficult, because introducing students to the discipline of architecture is big enough. And yes, of course, they get introduced to engineering input of one form or another. But actually, do they engage with this being a collaborative, creative process? Rarely, I would say. But in practice, more and more now, it is that a true collaborative process where many different disciplines are coming to bear. And so we must, also part of our process of education must be to understand and respect those other professions. Right, so there's the lecture, if you like. So a little bit more detail on this. So I'm splitting it into knowledge and skills in terms of, in a way, architectural curricula, of course, when addressing their learning outcomes and the modules that are set, identify what new knowledge or skills are going to be imparted as a result of these modules. Well, of course, the knowledge element, and this, forgive me if this is rather crude, but is often imparted through the process of lectures and seminars, workshops, etc., sometimes fieldwork. And skills, for example, in developing our ability to use analytic tools of one sort or another, are imparted through workshops and training. Now, so I would say probably collectively, we're probably reasonably good at those top two bubbles, if you like, getting across new knowledge, principles of environmental design, for example, or in helping students to get to grips with analytic tools. So that's relatively straightforward. What's not straightforward is actually how you then put that together in the design process. And of course, the design process has traditionally, and will remain, I'm sure, studio-based. So how do we get this into the studio? Well, this is problematic, isn't it? Because design, how do we learn design? We learn design by doing it. So it implies that design tutors must also be environmental design, sustainable design specialists, or they must at least understand this, and they are not. And that's probably what, or I'd like a show of hands as to anybody who thinks they are, because in general they're not, I'd say. Oh, there was one, sorry, Klaus, yeah. Do interrupt, actually. There's a series of questions, rather. And I say that also being involved. I'll come in a minute to a design module that I'm involved in at Nottingham. Anyway, so my point here is that I think one of the critical issues is how we engage with the design process. The broader subject is what we might call sustainable design. I'm kind of referring to what might be a part of that here in environmental design. And how do we integrate the environmental design knowledge and skills within the studio? Well, firstly, we need to, like most design projects, we need to understand the context. I'll come on to a little illustration of all these points in a minute. We also need to understand profoundly the site and microclimate, and it's amazing how often both context and site and microclimate are ignored when setting design projects in the studio. Thirdly, if we're trying to really understand the environmental design of opportunity within a new building, then we need to define or at least understand the environmental design criteria which are pertinent to the problem. So, for example, what lighting conditions are appropriate for a particular activity? Not just the quantity of light, but what is the quality, perhaps, of the light that one wants to achieve in a particular space or for a particular activity. And we need to have that up front. That's part of the analysing the brief, really. We need to have it there. And then in stirring all this around, and of course we do stir it, and it's an iterative process, so we've kind of looked at the context, we looked at the site and microclimate, we've analysed the environmental design criteria, and we begin to postulate an idea. And that idea can come extremely early on. In fact, the earlier it comes, the better, I'd suggest. And of course it'll get kicked around and some things won't work, but it needs to be expressed and discussed in the form of what I call environmental design strategy, and that should cover a whole raft of issues. Then, of course, the next process, part of this is we refine it and we test that strategy. So we use our analytic tools to explore whether it works or doesn't work. And then when we, collectively, we decide that this is an approach that is worth pursuing, then we begin to refine this and hone it and develop the design in detail. So what I've tried to outline there is my view of how we might formally integrate issues in the design process. Now, to just illustrate this a little bit further, Simos, you'll have to shout at me about time, because I know about... just a little anecdote about understanding the context. I was involved in a competition a few years ago with Mario Cucinella and Arups and Mark Hewitt, actually, from D Squared, and which, astonishingly, we won. It was a large... it was a redevelopment of downtown, the fort area of Colombo in Sri Lanka. In the process of looking at this project, we went over there, of course, and looked. We tried very much to get into the context. And we were told an anecdote about the two tower buildings you see on the right-hand side. The two towers there, which were erected by a developer who felt that he'd made his money in Southeast Asia. He came back to Colombo, and he wanted to put his country's capital city on the map. And the way you put your capital city on the map is by having some very tall office towers. So he had the money and he had the political muscle, and up they went. And of course it's a big deal, so when they were opened they had the president, the prime minister and the whole cabinet there, and they switched on the lights, and the rest of the city, nearly the rest of the island, went into darkness. And this reflects a lack of understanding of the infrastructure. It couldn't cope. There was no analysis of the infrastructure. And so this isn't anti-tall building. I'm not saying that. It's a different issue. It's understanding the context. Right, site and microclimate analysis. Well, yes, we do that, don't we? Or do we? Again, when we have a site, sometimes we see the perimeter of that site as being bounded by the plot of land that the developer or the client has identified. And we don't look at the wider site, which is, of course, the city environment. This is a Singapore proposal with Ted Cullinan for Singapore Management University. Just very, very briefly, what we found in looking at Singapore was that the street pattern, which, of course, I'm not precisely sure, but it had probably been set in the 18th or 19th century. Anyway, this very clear grid which went from southwest to northeast, which just happens to align with the directions of the south, the seasonal monsoon, the change in monsoon winds from southwest to northeast. Now, this actually isn't, of course, by accident. It was very much because the city pattern was laid out at a time when there wasn't any air conditioning. And so that air movement at street level was fundamentally important. Now, that then enabled us to explore the opportunity for encouraging that air movement through the city, through the streets, and through this complex of buildings. And it's wider issues of that kind. So on then to the strategy for the building or buildings themselves, and how do we develop that? Well, this is where it does require some knowledge of basic principles, and that's where the knowledge input from lectures, seminars, etc. comes in. It also comes from a knowledge of precedent, other buildings, other projects that people have done, historical as well, very useful. But it also fundamentally involves an integration with the basic organizing principles that underlie the planning. And that is fundamental too. And can only be engaged with in the studio, at the drawing board, face-to-face, between the tutor and the student. So, we've developed, this is a highly hurried up process, but we've got our environmental strategy, which we're beginning to believe in. We want to test it and see whether it works. Well, of course, now this is where all the tools that CMOS and colleagues have been teaching you about enable you to begin to see whether the strategy works or not. And we now are very fortunate in having a fantastic raft of tools at our disposal in order to do this analysis, both of the individual building, but also at an urban scale. And increasingly, of course, this will be a very important part of your armory in persuading your client that it works, but also persuading the planners that it's going to be acceptable in the context of the wider city. And this is becoming a more important part of the agenda, that planning authorities, and there was a recent publication of a sustainable plan for the borough of Newham in East London, but increasingly the London boroughs are mapping out the criteria for new development, and actually convincing them is going to be very significant. So actually we are beginning to have more power on our side, that in practice architects are being forced to address these issues because it's a planning issue, it's a planning concern. So yeah, testing the strategy, design development. Well, this is a very quick run through, again, illustrating a process of development in a project we worked with John Pringle and Pringle Richards Sharratt for the Manchester Justice Court. Looking initially at the block modelling in relation to the site, how that affects shading, etc. Then looking a bit more detail at initial sketches of how we might respond to that context in terms of the density of the site, what we had to get on it, etc. Then refining that a little bit further, how do we get the air into the floor, how do it cross the building, how do we control sunlight, all those things. And then further down to the individual room level, and then beginning to look actually at dimensioning it. And of course this process requires a great deal of commitment to the original strategy. You have to hang on to it and fight for it, because progressively through the course of the structure people will nibble and nibble away at it, and you have to be convinced that your idea works, totally convinced, and you have to also completely convince your colleagues, otherwise it's not going to get there. M&E engineers are going to come in and they want to fill, for example, this floor void. They'll want to fill the floor void with ductwork or something, or the structural engineer will. You've got to have all these guys on board, because if they're not, they'll find reasons for making it not work. And my principle is, and I used to have lots of arguments with Alan Short about this, and it's painful and horrible, and you're nearly at blows with each other, and you say, and he says, it can't be like this. And I'd say, well, but it's got to work. And he'd say, yes, but not like that. And I'd say, but it's still got to work. And so gradually you kind of dance around each other, and then hopefully you get somewhere where it's beautiful and it works. And I think we can go for both. We can definitely go for both. But you've got to hang on to it. Right. What are we doing? Well, this is, I suppose, I've extracted this from our mission statement, which is a bit kind of strange, but we hope to produce, I hold my hand out, graduates equipped to meet the contemporary challenges of facing the built environment professions. And we hope to have staff engaged in leading edge research, etc. Well, we do, and we are, and we do. And part of that is a very strong commitment, and it is historical at Nottingham, an historical commitment to cross-disciplinary teaching and research. And so that there's a very strong engagement of engineering and building physicists with architecture, and vice versa. So there is that strong engagement. And of course, I often show this slide on the right of teamwork, because of course everybody arriving around the table comes with a different agenda, and that will always be the case, and it's particularly the case in building design teams. But if you have a grounding in understanding a little bit about what makes each of the specialists around the table work, or quite a bit preferably, then you can speak their language and it can work. Right, what else are we doing in Nottingham? Well, when I arrived there, I felt that one of the things we need to engender is what I call design leadership. And I went up there. Yes, I'm an architect by training, but I'm not known really as a designer. In fact, many architects regard me as an engineer, and many engineers regard me as an architect. I'm in a really bad way. But, and so, in a sense, there was a kind of credibility gap there. And I said, well, I hold my hand up. I'm not known as a designer, but we can get these guys in. And so we've appointed some very prominent practitioners who come as visiting professors, and this is not nominal. They are booked in. They give us 10 or 12 days a year of real time in the studio and in giving talks, etc. And it's been a fantastic catalyst for change within the school, and it's raised expectations, and it has been a very good thing. We have also appointed other specialist professors to provide leadership in other areas of the school. In parallel with that, I feel it's fundamentally important that architectural education is grounded in or strongly linked with practice. I say that without, I absolutely committed to that, because if it's not committed, if it's not linked to practice, then we're in danger of going up a very narrow alleyway. And I've lost my thread a bit. Links with the professions and industry, I think, are fundamental, because practice can inform education. It must. We're dependent on the engagement of part-time practitioners in the process of education, of course. But equally, and I'm sure one reason why many practitioners do engage in architectural education is because they get a lot back. And so it's a two-way process. And so as Alexis was saying this morning, it's a combination of both theory and practice. And we need the two. But if it's my strong belief is if it's too strongly theory-based, we're in a big trouble. So we have all these connections with industry and practice. So, and we got some fantastic students, and yes, making things one-to-one. I want to make. I hope that in our school we will be making more of this. This was a project which some students were asked to design a stand for what's the thing in Birmingham each year? Interbuild, thank you. It's up there, is it? Right. And this stand, designed and made by students, was the big hit of the show and commented by everybody. In fact, George Ferguson said that it knocked Will Alsop's stand into a cocked hat, or whatever the expression is. Anyway, so we want to be involved in making things full scale. Now, how much time have I? I've probably overrun, haven't I? Yeah, wildly, right. I won't tell you about the Jubilee campus, but you can all come and visit it. And I will just very briefly tell you about a symposium we're having on the April the 5th, if I may, Simos, and which addresses these issues in perhaps a wider context. We're looking at or exploring the implications of climate change and economic growth on the built environment in Europe and Asia, and that's on April the 5th, and I'd love to see all of you there. It would be great. Thanks very much.
Thank you, Brian. In fact, I should apologize for putting people under stress. In fact, it would have been a great joy if each one of the speakers was coming for a whole day, and then we would allow them to speak without any interruption. The next speaker is Willy Weber. He's a professor of architecture at the University of Geneva and the director of the Research Center on Energy and Environment Problems of the University of Geneva. His research team has worked on many research projects and also on software development, and we have frequently collaborated both in the past and recently. Willy.
I just apologize for my English, but I brought some slides, so it will be easier to comment. well, it's Brian Ford were talking about the relation of practice on theory, and in Switzerland now is a political trend to put theoretical research in university and apply the research in technical school. And thank you. And in this context, in the contrary, I would like to show the richness of working simultaneously on different levels like research, survey, monitoring, and on teaching. So I will speak of our experience in CUEPE, the Centre Universitaire d'Études des Problèmes d'Énergie in Geneva. We have multidisciplinary people, architects, economists, physicists, and we are teaching in the Architecture School of Geneva, in the Faculty of Science sometime, and also in the Academy of Architectura in Mendrisio. And so it's nice, we see many students and have some experience. And our research in the center is in the field of decentralized energy production, development of renewable energy, rational use of energy according to demand in buildings. But today I will focus on a very small problem, is the summer comfort on overheating in glazed building as an example. It's really a growing problem and quite interesting. And you know why glazed building are growing? Because glazed improved. In a few decades, U value went from 5 to 1. Is working on layers and so on, and also the facade technology developed and gives many possibilities. And also now it's students, architects are very fascinated by the transparency possibility in buildings, and that's wonderful architecture, but often gives problem in summer. And also I have to say that solar architecture was speaking of the advantage to put glass and to have gains in winter, and that's true, but now it's a problem of summer. And I don't want to say that we don't have to use glass, and glass still build nice glass buildings, but first I would like to show how to understand why we have this problem, and they maybe give some key to be able to build nice glazed buildings that works in summer. That was, for example, I give some examples that we had with students. We have a postgraduate diploma in renovation, and one of the students took this nice building from Dominique Perrault. The text is kind of poetry of the beauty of this building. The problem is that people are complaining, overheating, glare, cold in winter, and now the building is half empty. They don't know how to do, but it's part of the architectural history of France, and difficult to make something with it. And with Olga, we know that now for east-west you have to vertical louvers and horizontal in south. And one problem is these buildings that you have horizontal louvers all over inside, on the inside for the building, so it gives that one of the origin of the problem. Just to show you some of the problem we we had to make a survey of, for example, this is an office building that had overheating problems, and the owner asked engineers, said, well, no problem, we put air conditioning and so on, but first they asked us to look the origin of this problem. And one thing you have here, blinds in between the windows. and we measured temperature on the surface of the window. And you see when it's sun, here is the sun, is going up to more than 40 degrees or even to 50 degrees. So we have a radiator during summer, and well, some solution was to put outside blinds, and then the problem was partly solved. Also, a building from Theo Hut, a very famous architect in Switzerland, at least, is building many. Here is a dentistry building for the University of Zurich, and users are complaining. Same thing. He make both, you know, blinds between the windows, louvers facing east and west on horizontal. And here it's another case. Interesting is a very nice building in Mendrisio that with a nice integration in the site, opening on the garden and so on. It was built by after a competition by Turkish Soliman, and it is the last building of the Accademia di Architettura di Mendrisio from Botta. And inside you have also that's a nice atrium with here you see the roof of the main hall. But also here problem in the corridor, you get temperature over 40 degrees during summer, and really doesn't work. It's a real problem, and we had to make a survey. And it's kind of interesting to be able to work together, making measurements, simulation, and also use this information to teach students and have students in the building to see. And it was quite an interesting thing. Well, some key factor is first we have good glazing, we have now very thick insulation, and when solar energy comes in, then it's a real problem. So you have to avoid solar energy to come in, and the first thing is to know where our problems can happen and to make some solar simulation. Here it's see from the sun, and we develop some tools, because if you take a facade northwest, you think, well, it's a north facade, no problem. But if you look carefully, you see that from 3 hour p.m. to 8 hour, you have sun. Yeah, still to say no, it's a north facade, but you have still 5 hours sun during the day. So it's solar geometry is not evident. So you have some little tools to understand, and that was also very interesting. Is was a little building made in Basel, kind of put together all new kinds of blinds, windows, so that architecture can go and show how it works, how it looks. And one thing that this coefficient is quite important for solar. It's called the G. Is part of energy, of solar energy coming in. And you see between Venetian blinds were inside and outside. That's usually what is demanded to avoid overheating, and the inside solution are very difficult, even if it's what architect wants to have the purity of the glass. And just, you know, the CG is not evident, because when you architects think what important is part of radiation, solar radiation that's come inside, but you have not to forget part is coming, you know, part of the solar radiation is absorbed, heating the glass, and part is coming, of the energy is coming in through radiation, part to conduction. And if you see, like, engineers are giving which G value you have to have, you can have If you follow, you can have 1.2 related to the glass part of the facade. And you know, it's really difficult. First, you don't really know for architect what it means, this U value. Second, it's difficult to calculate because the glass, you will know but if you put blind before blind, you know his G, but both together working, it's impossible to know. You have really to measure. So it's a relation always having very precise values for something that you even can't calculate. So it's, another factor very important is mass, storage capacity. And for showing the effect, we use what we developed in PEM that was measured in Lyon. That is the famous École d'Architecture from Perrault Jourdain. And it's interesting that on the basement, the lecture hall are in concrete, very heavy. And the atelier are very light. If you see here as measured during a summer, here you have red is outside temperature, and the violet is in the studio. And you see that when the light is following the outside temperature, going même over with Leon 40. But in the mass here in the lecture hall, you have some continuity, some stability with this. And just to show, another thing is the ventilation is an important. Going back to this Canavé house from Architectura, Accademia Terroir from Mendrisio, we measured the studio and we make some simulations that showed that with some solar protection, with a good night ventilation, we could quite lower very drastically the temperature from the soil. And so, I mean, that's the main clue of this thing to avoid this overheating in these buildings. But it's important not only to show bad examples, but to show also good examples. And we also try to develop some database of nice buildings, not only glazed, but some that works. And it's here, it's a database that you can find on the internet. That was developed in a European project called IDEA. We have here 60 buildings that you can select through the use of the building or devices or geographical situation. And for each house you will find plans, concepts, details and so on. That should help students and architects if they want to build something different. So last thing is that when with a good envelope you can lower or avoid or even lower the demand for cooling. It's passive solutions like preheating and cooling with heat pipe. And we measured some installation on this one of these in this complex of in Geneva, where you had many things. You know, you have solar roofs, you have these earth pipes and so on. And here it's just to show also in this example the relation between theoretical studies and applied studies. That you see the installation of this earth pipe, quite important and impressive and expensive. And you have to know always it's two main solutions. It's work and the average temperature during a year, or the average temperatures from a day, and it's a very different dimensioning on systems. And Often it's confusion with systems that are used. And just coming back to this, but first, for a thesis, it was really a mathematical study and analytical study of this problem, and tried. What's interesting to come back with some simple rules to dimension, and well, here are some simple rules that can the surface of exchange for cubic meters of air. That is, on the one thing is to know if you average year or average for days. The second is, do you use this system for preheating or for cooling? It's not the same thing, and we saw that preheating with now the good heat exchanger that you find is not so interesting, but for refreshing you have no other solution. So we prefer dimension this, especially for for cooling. Well, and then going from this, the idea was always we work now with the average temperature from the day. Why not trying to have the night, the lowest temperature from the night for the day? And the mathematical work in his thesis show maybe a possibility, and the idea was to make this shifting of this phase, you know, to use during the night you use external temperature, and then during the day you use the air from the night giving from this shifting. Yeah? So you have always day and night the lowest night temperature. And we tested, we developed some tests, and seems to work, and it would be has to be very careful because you have very precise exchange, many exchanges, air exchanges, and also continuity of flow. So we could develop this and also apply it to renovation. That would be quite interesting. Well, conclusion. I think it's we should not split and always keep a relation between. Well, here it's not, but applied or practical experiences with theoretical research, because it's going back. In this last research, we saw that many theoretical points about heat exchange had to be studied again. It could maybe be the subject of a new thesis. And also I think to be able to involve sometimes students looking what's happening, how you measure, what are the problem, is quite interesting. So for this problem, I think we, Alexandro was talking yesterday about, I don't remember, medicine, like you are the medicine of this problem of overheating. I had to find some medicine to avoid problem or some case to lower this. Thank you.
Thank you, Willy. And I forgot to mention that Willy Weber is, and his colleagues will be organizing one of the next PLEA, Passive and Low Energy Architecture conferences, PLEA 2006, in Geneva in September 2006. The next speaker is Kazuo Iwamura. He's a professor of environmental design at Murashi Institute of Technology in Yokohama, Japan. As a young architect, he worked for George Candilis in Paris and then also in Athens, and later moved to Germany in Darmstadt, where he opened an architectural practice with colleagues before going back to Japan to start his own studio, Ibamura Studio. He's a member of the board of directors of Japan Institute of Architects and co-director of the UIA Architecture and Sustainable Futures working program. And he's also the organizer of a major conference. I'm sure he will tell you more about it. Thank you.
Thank you for kind introduction. Well, I have only 15 minutes, so I have to rush into my presentation because I have almost 90 megabyte or something like that. Well, it's my privilege to be here, to give a lecture here in AA, because AA is quite well known for good design, but they're ignorant for the environmental issues. It's my understanding. So I think it's very good to be here to talk about that and to talk in front of the students of the AA. Because my son is also studying here for the time being, so it's quite interesting today. So my title is Kaleidoscopic Showcase of Best Practice in Japan. I don't talk about the theory. I'd like to talk about the action. We needed action for sustainability now because we talked a lot already. So we have to do something. And so this is introduction. My presentation refers to part of the best practice of the architecture for a sustainable future. This is a program at UIA, and which is executed in Japan since almost 2000. And 20 selected projects. Well, this is original paper. Now I'll show you a 10 project, among others enclosed. Those awarded with major related prizes or those accredited by the relevant authorities and other outstanding ones. So first I'd like to talk about a design process, which is also main issue to me in university. By the way, I'm a practicing architect and at the same time teaching at university. So I have the 3 phases for design. So I teach also students according to this design process. First, pre-design, and design, and post-design. A pre-design means determining and assessing the specific features of the project according to natural environment or social cultural environment and project circumstances in order to elaborate the concept and objectives to be shared by all the stakeholders. To me, most important thing is maybe social cultural aspect. I'll tell you later why. And secondly, developing the best practice of the program in both hardware and software and every life stage of the project, from ecological, regenerative, technological, social cultural, aesthetic, of course, and economic viewpoints, to be followed by the execution on site. So that might bring the diverse solution of the sustainable architecture. So after this design phase, which is, to me, is very important, I work with the students very often, implementing environmental management through post-occupancy investigations, evaluations, including consumer satisfaction researches. While that is very, very important, we can learn from this phase a lot to improve the design, improve also pre-design phases. So this design phase goes back to and goes around in spiral way. So this is our fundamental attitude towards the architecture of sustainability. So I don't know who the people here, if they know about Japan. So I'd like to show the general characteristics of Japan. This is archipelago, stretching from north to south, and we have a lot of different climate zones showing like here. While it is defined by energy conservation standard by the nation, 1999, it is bounded with the municipalities. So we have semi-Arctic till subtropical regions like this. And then I will show you today 10 examples according to these zones. northern zone, and intermediate zone, southern zone. Tokyo belongs to intermediate zone. So part one, residential case illustration. So I'd like to introduce you a very important national policy drive since 1990, which is called environmentally symbiotic housing. I have been a major consultant to the government since 1990, well, 15 years. And the objective is a protection of global environment, and we call it low impact. And secondly, harmony with the local environment, high contact, we call it. And then thirdly, a healthy and comfortable living environment, health and amenity, which is very popular all over the world nowadays. So, well, this is a holistic image of a symbiotic housing complex, which I developed for my own project. So, 1998, we have also released accreditation guideline of environmental symbiotic housings. You see this is some criterion to be accredited as environmental symbiotic housing. So we have at a foundation compulsory measures, which is very basic one. And then we should have at least 2 columns to support roofs, which correspond to the energy conservation, natural resource saving, waste and reduction, harmony with the local environment, or safety and health and amenity and so on. These should be superior measures compared to the compulsory measures. Well, this is a rough image of this accreditation guidelines. Well, some example of accredited solutions, for example, integrated solar power system on the left. It is one example for energy saving. And on the right, recycled material that could be used again and again and again as resource saving and so on. So cumulative number of constructed symbiotic housing accredited since 1999 is almost 2 years ago, more than 30 dwelling units. So even industrial housing supplier, they also provide some accredited symbiotic housing like this. You see on the pamphlet on the right. So what is really interesting to me and very important in Japan is the OM solar system, which was created by one architect 15 years ago, and then is now put into operation in the market. It's very popular now. It is a very simple system that the air comes from the bottom of the roof and go up and heat it up through the roof and the glazing on the rooftop. And then it was propelled down to the cavity floor and it would accumulate it on the slabs. And then warm air come into the interior, and also in the summertime it could be used for hot water, things like this. Well, this was very simple system, and number of OM solar houses constructed during the last 15 years, almost more than 25,000 houses is incredible number, but this is very good welcomed by the people in Japan. So now some case restoration in Sapporo, I mean here, northern part of Japan. And this is one of my friends, a close friend of mine, he's an architect. He developed this prefabricated system. It's a timber house, which is called B house. And this is very affordable and very good, very high performances in terms of its insulation and so on. And it could be also built within 2 months. It's very quickly done. And also, the users and customers can participate into the construction period. This is also a very important aspect. Well, look at this. Prefabricated building elements allow the partials of built. Well, anyway, this is very affordable in comparison to the normal Japanese construction method. So second example is my project, which is Setagayaku Fukazawa Symbiotic Housing Complex. This is a public housing which was constructed in 1997. Public housing is subsidized, is 100% from the states, the government, state government and the prefecture and the municipality. And this is also rebuilt, world-owned social housing. This is a leasehold, and 70 dwelling units, daycare center, and community facilities, and so on. So this is a situation before the rebuilding, 50 years post-war community environment before rebuilding. And in this project, which is very much important, was the social aspect. So we tried to make a participation program of the people and to make embedding the memories together. So you see the people working together, the people from the municipalities or from office or residents and so on, and became later a part of the environment. And then this is a very important aspect because after completion, if the resident participate beforehand, they take care of the house very, very carefully. So that could be very sustainable for the building itself. So another aspect of this building complex is the buffer zones, which is, to me, it is very important in Tokyo area for climate, local climate in Tokyo area, and for better quality of life and less environmental loadings. I don't go into the details, but anyway, so I put also greenery on the rooftop, and this is some aspect of the post design. We made it with the students together in the university, and how does it work? How it doesn't work. So if it doesn't work, we have to remove it, improve it. All the stuff is very, very educative for both teachers and students as well. So at last, this is CASP scores. This is the new Japanese assessment system based upon the PRIM or LEAD and whatever, but which is conform to the Asian context. So which is very characteristic is you see this graph here, and horizontally is a building environmental loading, and vertically building environmental performance. So we have the BEE, building environmental efficiency, Q by L. Q is quality, L is loading. So all these factors, indicators are sorted according to Q and L. So we can show every indicator, Q1, Q3, Q3, like this to the bar graph, and all together like a radar chart. And then at last, we have this number BEE, in the case of the Setagaya, 2.2. So this is quite high. And of course, less building environmental loadings and more higher performance is better buildings. So S is the best one, A, B plus, and so on. This is a classification of the assessment. And this building belongs to A. So another example is also some residential complex, which refers to the microclimate design, microclimatic design using existing trees. What existing trees, how does it function to the environmental improvement? So this is some post-design assessment here using infrared photographs. And so what I'd like to talk to you is this comparison, case 1, case 2. Case 1 is the trees are preserved, case 2 is not preserved. So if you calculate the loading on the houses for the heating load and the cooling loading, and then first year, you have here electric power consumption and then CO2 emissions. So after 50 years, using the existing trees as some design aspect for microclimatic design, 52% reduction will be provided. So this is the some sort of researches which was designed by the architect as well. So this is another aspect is, it is my another project, Yakushima Symbiotic Housing, which is totally different situation as my preceding project, which is also publicly owned social housing, leasehold. And this is on this small island, on a subtropical island like this. So this is a typical housing block, which was learn from the rich vernacular heritages that you see the right down here. So traditional closed layout and houses protect each other against the typhoons, and open interior providing flexibility and natural ventilation is the priority. So here we have a lot of typhoons. Every year they have the more than 10 typhoons and so on. So that's why we should consider the form of the houses and so on. So it is intentionally closely laid out. Well, it is based upon also vernacular solutions. So next one, well, this is also a very important aspect in village scraping, and this is the overall image of the ensemble, well, which is totally different from the Tokyo examples. So non-residential case restoration, I have no time here anymore, but one or two let you explain about that. But this is also one very interesting building which was built 2002, and this is the section of this building. The most characteristic part is the ice shelter here. This ice shelter, because here is very cold in winter time, 15 or 20 degrees below zero, so using this coldness, you can produce ice. So this ice could be used for summertime for cooling. So this is something very important aspect for passive cooling and heating. And also they have an atrium between laboratory and office to use for natural ventilation, on daylighting and so on. So through these measures, they could reduce the more than 50% reduction of operational energy consumption. So another example is, this is also my project, which is a pavilion from Expo 2001 in the forest, which was timber construction. And then what is important is a pavilion for the exposition should be usually destroyed afterwards. But this time, we tried to remove all this construction and relocate the building somewhere else. So that's why we try to rationalize all these details like this, and using the timbers in the market, no special timber like this. And then afterwards, the green building like this, and then in interiors was like that during the expo. And then afterwards, with dismantlement of the relocation, and that was relocated afterwards in somewhere else for permanent use. So another example is, this is a most advanced, maybe environmental building in Tokyo, but I think it's too much a little bit. But anyway, this is a good example, which was also done by the competition. They have every kind of gadget attached to this building. But what is very interesting is passive solar energy. Well, for instance, this is a geothermal cooling and heating system, and using underground gallery. And there's also atrium. Well, atrium in between is very popular in Japan. And well, this is a very understandable illustration for the natural daylighting, and for the south, from the south and from the north as well. And also this light shelf, which is integrated into the architectural design as a vertical louver like this. And the other, all this gadget, and reduces the operational CO2 emission 50%, and the LC CO2 emission 40% reduction. Well, this is calculated like this. And CASB value is 6.2. This is very, very high. Well, I skipped this project. I go to the last project, because which is very characteristic for Japan in the southern area, and that one here. This is Okinawa. It is very large island on a subtropical area, and which was also built by competition. This is City Hall, Itoman, and which is most important aspect to how to make shadows for the buildings, and natural ventilation and so on. So you see the solution like this, and using also photovoltaic, and also this is based upon the vernacular solutions interpreted into the new design. And through these measures, operational energy saving is 20% reduction. So that was some examples. But still, there's some very interesting examples like this. This is a tea house. It's a very famous architect who did it by himself with his own tea room. You know, this is swaying all the time, and it's very small. And well, this is also somehow very sustainable because it is using it uses very local materials and built by himself. And then it doesn't correspond to any building regulation because this is too small. So at last, I'd like to introduce some information for SB05 Tokyo. It will be held in September this year. It's going to be a very big international conference in terms of sustainable building. And we had already accepted more than 1,000 abstracts, and we received now the full papers we are now assessing. So we'd like to welcome you all of you, to this conference. Thank you very much. And there is some more papers on my slides. If you want somebody else, then come to me, please.
Thank you. We should be taking a break, I think. But we're also running half an hour late. Anyhow, I'd like to introduce the next speaker. Geraint John is an architect with long experience in the design and construction of sports buildings. He's a professor of architecture at the University of Luton. He's a member of the RIBA Council, and also, as you heard earlier, the director of one of the UIA work programs, the one on sports and leisure. Again.
Colleagues, thank you very much. You must be getting very tired of receiving all this bombardment of information. And maybe you'll be more happy to know that I'm going to be very simple in my presentation. The first thing, because we've heard so much today, you'd like to change what you had already written and what you proposed to say. And the classic way of people doing this is to say, I'm going to tear up what I already wrote today, and I'm going to now speak to you from the heart. But of course the slides will come up as normal. But I want to just make some remarks because we heard quite a lot of things today. We maybe have time for discussion afterwards. Brian Ford said that he was told to disagree or agree with what's being said. Well, we can't do that because this is such a complex and huge subject. There are so many waves in it. And we heard from the other speakers. We heard Nikos Fintikakis talking about, he brought us back to Aristotle. And I know I have visited some of his projects, which he showed, and they are well worth visiting. He's a very, very good architect. And Dean Hawkes told us, too, that the word sustainability comes from Old French, and before that from Latin. Now, this is the first time that nobody said this came from the Greek, because always these words come from the Greek, and I'm sure we're going to hear later that this word really did come from the Greek, with so many nice Greek people here today. Susan Roth talked about the depressing world situation, and what do we do about it? What do students do? What do architects do? I think Shuttleworth said that the architect is in the best position to effect change. And I think this is, in a way, a very arrogant thing to say, because there are so many world tendencies that we can't control. What do we do about the USA refusing to sign the Kyoto Agreement? We heard about that today. What do we do about tourism? Everybody is doubling airports, doubling the number of aeroplanes flying all over the world, using up all the world's fuel. What do we do about population? We have too many people maybe on the planet. What can they, well, maybe the students can do something about that, you know, not to have so many babies, but we'll have to see what we can do. Dean Hawkes also referred to Frank Lloyd Wright. You know, this was the man. When Frank Lloyd Wright was taken to the US Senate for un-American activities, he was asked a question by the committee. They said, "What is your name?" He said, "My name is Frank Lloyd Wright." And they said, "Who are you? What do you do?" He said, "I am the world's greatest architect." And then they said, "Isn't that a little bit arrogant to be saying that?" And Frank Lloyd Wright said, "Well, I have sworn under oath to tell the truth." But I think the days of that kind of architect are over. And maybe we have now to come back to a holistic approach, where it's not just the single architect and his creation. We heard about the ideas that we have to respect environmental services, we have to have an understanding of services, understanding of structures, and come together in a holistic way to understand and respect this problem. So my contribution today is to return to Alexandros Tompasis and say, with all these high and important things to do, what does the architect do on Monday morning about his project or her project? What can we practically do? And therefore I would just show you some sports projects, because that's what I know. Alexandros told us that the practice is, we can't go into wild word theories with the job. We have to be site specific, we have to be time restrained, we have to deliver, and the site practice is unforgiving. These are his words, and I absolutely agree with it. Brian Ford said that we have to link to with practice. And so what I'm going to show you today is a complex subject. Urban planning and sustainability links all of these things, as we've heard so many times today, to bring together what do we mean by sustainability. And all of these five are interlinked. They are not in compartments. And I'm going to talk today to you about my experience. The stadium and the arena are very large and important spectator venues. Somebody calls them the new cathedrals of our age. And this is the Wembley Stadium, under construction right now, will be completed next year. And as Alexander said, it has to be site-specific, and it has to be built on time. It's programmed to hold the Cup final in 2006. So it has to be ready for the Cup final in 2006. And no matter what anybody says, this is the fact of getting the building built. So what does Wembley do about meeting sustainability? It complies, of course, with all of the Part L increased futuristic regulations. Dean told us about a house that he built which was in advance of the regulations, and Wembley is going to be in advance of the regulations. The power will be supplied from renewable sources. We are going to separate the wastes for recycling. The crushed concrete of the existing building will be used in the foundations of the new building. And the building has been designed so that it's what we call cut and fill, so that very little material of the demolished building left the site. We save on a lot of vehicles being transported all over London, and so we built in the old building as much as possible into the new. And of course we come to public transport, which means that there's no car parking here. This is a city centre building that we're going to talk about. And just to show you the scale of the problem, the red profile shows you the size of the old stadium on the same site, and the black building shows you the profile of the new building. And this seats almost exactly the same number of people, but to a much higher standard of comfort and dimension and safety, providing for disabled people and all of that. So that's the comparison with a new building with an old building. This is an American example of something we don't want anymore. We don't want to build stadiums and arenas like this, which are surrounded by car parks, using vast amounts of energy to get people there, big traffic jams, big road networks. We want now to concentrate on having public transport. And this is an example of Nikos showed us this morning, Athens. This is the Sydney interchange for the transport of people to the new site for the Olympics. If you know the situation in Sydney, it was a very green Olympics, very sustainable, and indeed, when we talk about world bodies setting a good example, the International Olympic Committee is one of these bodies that's really good in this respect, because you don't get the Olympics for your city unless you can show that you've paid respect to the environment and to sustainability. And it's a very, very important message, and one of the few world bodies that actually is really doing something about this matter. This is the Sydney Stadium, used in Olympic mode. Afterwards it was changed to meet a different need, because it has to be sustainable in terms of its use afterwards. And some of these things show you what we did about the design in terms of sustainability. We used the water from the roof, collected that together, which is going to be used for grey water, flushing toilets, washing in the stadium, and of course watering the pitch. We designed the building to try and avoid using air conditioning as much as possible. In other words, by designing the building in a way so that natural ventilation provides as much airflow, and avoiding the use of complex and expensive air conditioning machinery. And this is one of the ramps to the building, which again was built into the system to try and get air moving through the whole stadium to provide natural ventilation. Water regulation, I told you about that. We're reusing the water. And this is a kind of theoretical design for a very small stadium, whereby it incorporates, I think, many of the things that we've been trying to talk about today. Solar panels to bring energy. We have big roofs on these buildings. You're reusing the water, thinking about how the building reuses the site. And this was a very small stadium in France, in Amiens, which I think kind of obeys these principles. Very neat little building, and built into the ground, half underground, so that they just shaped the stadium out of the earth. They didn't bring any new materials to it, and they didn't take any away. They just merely molded the landscape. This is an example from Germany, showing, of course, solar collectors on the roof for the stadium, providing all the energy that's needed. And in the previous presentation, we heard about an atrium. This is the new racecourse at Ascot, which provides an indoor atrium, again improving the kind of energy performance of the building. This is the new Arsenal Stadium in London, also under construction. This is a building built on a brownfield site. All the timber will come from SSC accredited renewable sources. We avoid the use of PVC in any materials that are used in the building. These are the kind of practical things, instead of the global messages that we can do. These are practical detail matters that can be applied to the buildings. We are going to use only water-based treatments for timber without any kind of pollutants in them. We are going to process the waste from the building. And there will be the zero use of additional low formaldehyde MDF. And MDF is a very controversial material now. And so we're going to do it the best we can. And once again, transport. To this site, it will be public transport using the public transport network of London. No car parking. Nobody's going to come by car. Everybody will come by transport. And the lighting of the stadium is very good. This is Cardiff, once again a downtown stadium in the centre of Cardiff, which Dean will know very, very well, but it's a city centre site, so the building can live in the city centre, and it's built on the river and has a movable roof, so the stadium roof can be closed. Now this is another aspect of sustainability. It means multi-purpose use. It means that this building does not lie idle. It can be used for many, many purposes. For concerts, and people can be protected from the weather when the roof is closed. And of course it's the home of the national team for Wales who play rugby, and this is a very important matter. And the roof therefore has to open, because God wants to watch the Welsh rugby team playing in the stadium. And this is another slide. It's a very nice structure in the city centre. This is, of course, Munich. This goes back. I put this slide in because we heard Fry Otto lecturing in London. He was awarded the Royal Gold Medal a couple of weeks ago. And this is the Munich Stadium, and the whole Olympic site built for the 1972 Olympics. It's quite old, but is still, to me, one of the finest examples of an Olympic site that's ever been created. And it was done by reusing materials from the demolition sites around the city after the war. They built that hill out of materials that were brought to the site. The site was shaped in a very, very nice way, and it's an advance of current thinking, but nevertheless I think it's a kind of example that shows us what we can really do. And as of today, another thing is, if you design your building really well, then 30 or 40 years later it's still liked and used and not obsolete and meets user satisfaction, which I think is a very important aspect of building for long life. We talked today about long life, loose fit, and low energy buildings. This is a building with the outside skin by Richard Rogers, in which we are now, it's the Dome, the famous Dome in London, built for the millennium, and now we are inserting a permanent arena inside this building, which means that the building has a long life and has a new use to it, which again, it's a kind of reuse of existing buildings, and means that we are going to make the best use of existing buildings which last for a long time, give user satisfaction. And I hope that what I've said to you in a way gives you some clue about not just the kind of wide global theories, but of some of the aspects of how buildings can operate in practice and how we can deal with some of the problems which take us towards a better environmental solution. Thank you very much.
Thank you. I've been struggling with myself about whether to call a break, and I think maybe one suggestion would be that we do take a break now. We also have to load another presentation, to take a 5-minute break now, and then not to take a break between the last presentations and the round table. Okay, so it will be a very short break, just 5 minutes.